Washington. So he got the Nobel Prize. So he had to go and get it. But he didn't trust the Marines. And he didn't want to fly. So what the highest, I don't know who's the highest officer, the general, the Navy general, went to him, says, Buster, you're gonna go, right? And you know what? I go with you. So they got an aircraft carrier, the biggest boat they had at the time. And there was two gentlemen, and she didn't go. And the two gentlemen went to Copenhagen and got themselves the Nobel Prize. And I think he's no longer alive. But we here did this with electrons. So we did electron diffraction on molecules, on crystals, on anything you could get your hands on. And but this was not. We were not that far thinking. We just were thinking about. The biggest thing I did was hemoglobin. It was the biggest molecule I ever analyzed. Because again, that one, we had not known what the iron. I think I told you that I had not known what the iron is in hemoglobin, and we still don't know, by the way. Okay. So coming now from this stuff, we could slowly build molecules. And so what happened is, this is a little bit image now. So how they all hanging together. Yeah. So what happened is, right, so these are all the sulfurs. These are the sulfur chains, right? And then underneath the sulfur chains were these compounds. Then they found their partners, right? And then they found out, Mother Nature found out, we're doing particularly well when we group those in threes, all right? And then, as usual, every one of those three got an egg. And I don't think they're named here, but here are the names. I mean, these are these threes, this three, the condensate sequences, and here are how they arrange it. So this is now, you see, when you have, let's say, cover this up. Yes. And this. So you could go in and give every one of those guys a name, a couple of threes. This, this, and this. This, this, and this. So we can all couple it up, and you make a column. And here you see now here are these three compounds, these three columns, these which are above here. You can come down. So now you see, and the fine part is that the basic molecule is this one. Look at this. This shows up everywhere, right? And this one, this is changed, but this one is everywhere. And this is what they call amino acids. Okay? And these amino acids, they all look like that. C, O, O, H, and now the C, N, N, O, and O. And H2. Okay. And then now there is one bond left here, right? This is a double bond. And here you can hang in anything you want. So all these things here are stuff which Mother Nature found. This, by the way, this is basically glycine. Let's look at this. This part. This is glycine. I can read that. Glycine. This is glycine. So this is CO, double bond. Then this is C, single bond. This H is replaced by the top. There's another C, and then there's an NH3 group. You see this one. And this one actually has a name, and this is called glycine. Okay. And now with that, you can do a lot. And these are all these various amino acids. And as I said, this is, you get ram filled with that stuff. And so here is that, and you see that. That's how they, this is how they form. And now this one, this glycine, right? This glycine takes the bond, and these are these various compounds now from here, then OH on the end, and then here, and here, and here, and then H on this end. So this is your DNA in its basic structure. And this is the same thing what this is. Okay, so we have this phosphorus and sugar. Yeah, phosphorus and sugar. Phosphor and sugar, phosphor and sugar, phosphor and sugar. Then the same thing over here. And then we have these GCs or ATs, GC, AT, GA as a bonding part. And then they form these ribbons, which are then, as I said, they can go for on, they can go forever. Depends. We have cases when this was, so I don't know, we have here a professor in the 14th floor, Dr. Florin, and he makes these monster molecules and tries to measure. Okay, now I take one and bring it like a string, and can I make music with it? Bing, bing, bing. Well, you can't hear it, but the question is how much strength do they have to hold together? Then I change this in another solution, or when I go and change it to another temperature, and either a virus who attacks them. There's lots of fun. Well, I hope you have that too, right? And so what happened is this is now what we're going to do for a little while on this on the rest of the class, because I think that is important that you get this right. Now you have that one. So here's one what is sugar. Phosphor, sugar, phosphor, sugar, phosphor, sugar. And you can see how they're bound over the T's and the C's. So that's all these papers which I show you here. They're all on the web page, right? I can prove it to you because they also have that dirty rim on the side. The guy downstairs is the one to take the cane to make a color copy and cut the bed off. And so therefore, you're going to have this there. Okay, so go and look what you find in the web page. Sooner or later we start getting some homeworks on it, so that you can. So I give you just a row of A, T, G tests, and then ask what's the other side.